So, I am not drawing the switch here, can assume this VSW is driven by the switch which is goes from 0 to VDD. Okay. This is your PWM signal and this is your V out. So, what was the current, ripple current in the inductor, remember? VDD minus V out over L D times TSW. TSW is this period, okay, which means I can write it so if I have to draw the output inductor current, this is your so whether you assume a load or not, it does not matter because your ripple current will not get affected. Only difference, the offset of that ripple current will change based on the load current. So, if you are only interested in delta IL, then you can assume load current 0, you will get the same answer. So, this is your going from 0 to VDD. And what is the slope of this? Okay, that is the slope. So, if this is my so average of this will be load current I load, correct, and this is your delta IL. So, if I want to draw the output voltage, how will it look like? So, what is happening here? So, your input waveform gets integrated and converted into current, inductor current, okay. That is why you get your square wave gets converted into ramp. Now, what is the equation for capacitor? I equal to C dV by dt. So, which means V is integral of current. Now, this current will again get integrated and convert into voltage. So, you should have a parabolic kind of function, okay. Which means it will be more looking like a quasi sine kind of thing, okay, because you have a parabola. So, where will the peak and valley of that parabola or sinusoid looking waveform? So, average current below this point, what is the average current below this point? Positive or negative? negative, okay, which means output voltage will keep discharging until that point. So, that your value should be here at this, okay. So, if this is my value, I will just put a dot here. And now, if you look at take some light color, gray. Okay. And so, if you look at this shaded curve, which is above your I load, average is current is positive. So, it will keep charging, capacitor will keep charging until this point, where again your current starts becomes negative and capacitor will start, which means your peak will be reaching here, and then again it will start discharging. Okay. So, and even if you integrate it, your shape will be looking like this, correct. Then you come here, okay. So, this is your peak to peak output voltage ripple. So, how can I find this? If I need to find, one way you integrate it and find, okay, put the limits, you know the period in terms of duty cycle, you can do and find it. So, that is a straightforward, one straightforward way. So, and I know that if I want to find the integral of this curve, I have to take simply the area and, okay. So, and I know how much charge I am dumping in the, so area of this curve, the current will be nothing but your charge. So, how much charge you are dumping or drawing from that, that simply can be found by the area of this triangle. So, from here to here, this is the amount of charge. So, your peak voltage, if you okay. So, this is your valley and this is your peak. So, from here to here, how much charge you are dumping into the cap from this point to this point, which means the area of this triangle. Okay. So, I am interested in area of. So, you can do the same thing on this side or other side, you should get the same, because peak to peak is same for both the triangles. So, this is the area I am interested into, and this is nothing but, so if I call it, let us say A. So, area of triangle A I need to find. Half base into height. So, how much is the height? Half into, how much is the base? Ts by 2, because half of T on and half of T off. So, it will be nothing but T of Ts by 2. So, Ts by 2, height delta IL by 2, correct. So, this is 1 by 8 delta IL TSW, and you already know what is delta IL, this is your delta IL. So, from 1 here, so this is your delta. So, if I call it Q or Q naught, Q naught equal to 1 by 8 delta IL, 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 1 by 8 over L correct. Multiplied by, so TSW square, correct. Now Q equal to CV. If I apply this formula, and we are looking at a delta V voltage only, which means Q equal to C times delta V naught. This implies delta V naught equal to Q naught over C, which is nothing but 1 by 8 V d 1 minus d d over L C F S square. Okay, this is your formula for ripple current, sorry, ripple voltage. So, what does it mean? Which means output ripple is inversely proportional to, or let me short this, written in short, okay, and this is also so if you increase the product of LC or one of them, capacitor or inductor, then your output ripple will reduce for the same switching frequency, or if you increase the switching frequency for same L and C, then again your ripple current or ripple voltage will reduce, and that will it will obviously also reduce the ripple current, inductor ripple current in case of L and C, because C ripple current is not a function of capacitor, but voltage is, but inductor and switching frequency will affect the inductor ripple current as well. Okay. So, if I double the frequency, I get 4 times advantage, which means if I want to reduce the size of my L and C, I have to increase the switching frequency, and that is why when you target, let us say, order of tens of megahertz, the only intention here is to reduce the size of inductor and capacitor, so that your external components reduces and your overall module size is reduced, and you get the benefit in terms of transient response also, because higher switching frequency means you can have a higher bandwidth. Okay. So, how can I find the maximum ripple? So, let us say assume VDD is constant and D is varying, which means V out is varying. Okay. If in is constant, then the only way D can vary if output is varying. Okay. So, now we already know delta V out equal to 1 over 8 VDD 1 minus D D over. So, for maximum you have to just differentiate it with respect to, so D of delta V naught over D of D. How much is that? So, you will have a 1 minus 2D multiplied by 1 by 8 VDD over equal to 0. Okay. This implies, so at 50% duty cycle you get maximum, which means on the other both sides ripple is less, and if you look at here, this is a parabolic function, so it has a symmetry around 0.5 because it is a 1 minus d into d. So, if d is 0.5, then this product becomes 0.25. At any other duty cycle you will see there is a symmetry. So, 0.1 will be equivalent to 0.9 because one will become 0.1, other will become 0.9. Same is 0.2 is equivalent to 0.8. So, there is a perfect symmetry around 0.5. So, this is 0.5. If you go 0 to 1, and this is your duty cycle, and this is your delta V out. So, this will be your maximum. Okay. At 0 and 1, ripple will be 0 because one of the switches will be permanently, it will not be switching at all. So, that is why your ripple current and ripple voltage both are 0 there. What happens if V out is constant and V in changing? In that case also your duty cycle is changing. Huh? So, what would happen? So, can we write that this function in terms of V out? The same. You can write it. Huh? VDD into D is nothing but V out. V out into over. By the way, this curve is not only valid for ripple voltage, this is valid for ripple inductor ripple current also, because other terms are constant. So, 1 minus 2d factor will come in the current also. If you look at the current, so VDD into 1 minus d into d factor is same in both the cases. So, your ripple current will also peak at 0.5. Okay. Is this correct? 1 by 8. So, when you are looking at a maximum peak current, the only difference is the capacitor which comes into picture, otherwise the duty cycle portion remains same in both current and duty cycle, and voltage V out or VDD remains same in both current and voltage. So, these curves are valid for current as well. If you are assuming that capacitor is constant, it is not changing. V out is constant, V in is changing. So, what will happen to the duty cycle? Same as previously. No, D product is missing from here. Huh? V out is constant. When V in is increasing, what will happen? D will decrease. So, delta V out will increase. Correct. Which means, so D is inversely proportional to, correct. This implies delta V out is proportional to VDD for constant V out. Okay. So, at D equal to 0, the maximum ripple in this case will be at D equal to 0, okay, which implies that V in is maximum, okay. But at D equal to 0, usually it is a hypothetical thing, So, ripple voltage as such will be 0. So, you have to always look at higher than d equal to 0. So, let us say assume 0.1. So, this factor is 0.9, correct. So, and when you if you look at a d equal to 0.9, it will be 0.1, correct. So, almost 10 times reduction you get in that case, correct, 9 to 10 times. So, your ripple will be decreasing as you increase the d. This is delta V out. So, there is no parabolic kind of a transfer function in this, which means for the same voltage, if your V in is increasing, then your ripple current will be high. So, let us say you want to design a regulator for V out equal to 1 volt and your V in is varying, let us say from 5 volt to 10 volt. Okay. So, at 10 volt your ripple will be maximum, and this is true for current also, as I said. So, your ripple current will be maximum at V in equal to 10 volt or VDD equal to 10 volt, and that is why when you keep increasing the V in, you need an inductor which has a higher saturation current, because your ripple is going to increase and the peak current will be your load current plus the half of the ripple current, and at higher V in that is high. So, you need a higher saturation inductor for higher V in.